So we'll continue with the second chapter. So in the example in the preceding section, region ID and industry ID are given as not as plain strings like Greater Seattle area. Why? So if the user interface has free text fields for entering the region and the industry, it makes sense to store them as plain text strings. But there are advantages to having standardized lists of geographic regions and industries and letting users choose from a drop-down list or autocompleter. So, uh, so the question here is why not just give text fields where the user can enter uh, with his location and whatever his profession is. So the reasoning behind it is that there is a greater advantage to storing a specific list of professions or specific list of uh, specific list of industries to work in. So that's what is the reasoning here. The user interface has free text fields for entering the region industry. It makes sense to store them as plain strings, but there are advantages to having standardized lists of geographic regions and industries and letting users choose from a drop down list or autocompleter. So the advantages over having a text field is as follows: consistent style and spelling across profiles, avoiding ambiguity. There are several cities with the same name, then you will be avoiding ambiguity. Ease of updating. The name is stored in only one place, so it's easy to update across the board if it ever needs to be changed. So changing location in the location table, that will be easily reflected across multiple areas where you have chosen a location to be displayed. So that's one advantage instead of simply giving a text field. Another advantage is localization support. When the site is translated into other languages, the standardized lists can be localized. So the region and industry can be displayed in the viewer's language. So if you give a you can have a standardized list and each of these words in that standardized list can be translated into another language in a much easier way than when you're trying to enter into a text field. Better search. Example, a search for philanthropists in the state of Washington can match this profile because the list of regions can encode the fact that Seattle is in Washington, which is not apparent for the string Greater Seattle area. When you store an ID or a text string is a question of duplication. When you see an ID or a text string is a question of duplication. When you use an ID, the information that is meaningful to humans, such as the word philanthropy, is stored in only one place, and everything that refers to it uses an ID. It has meaning within the database. When you store the text directly, you are duplicating the human meaningful information in every record that uses it. Okay, that was intuitive. The advantage of using an ID is that because it has humans, it never needs to change. The ID remains the same, even if the information it identifies changes. Anything that is meaningful to humans may need to change sometime in the future, and if that information is duplicated, all the redundant copies need to be updated. This that incurs write overheads and risks inconsistencies, where some copies of information are updated but others aren't. Removing such duplication is the key idea behind normalization in databases. Unfortunate, Unfortunately, normalizing this data requires many to one relationships. Many people live in one particular region, many people which don't fit nicely into the document model. In relational databases, it's normal to refer to rows in other tables by ID because joins are easy. In document databases, joins are not needed for one-to-many tree structures, and support for joins is often weak. If the database itself does not support joins, you have to emulate a join in application code by making multiple queries to the database. In this case, the lists of regions and industries are probably small and slow changing enough that the applications can Moreover, if the initial version of an application fits well in a join-free document, data has a tendency of becoming more interconnected. Organizations and schools as entities. In the previous description, organization, the company where the user worked, and school name where they studied are just strings. Perhaps they should be referenced to perhaps they should be references to entities instead. The organization, school, or university could have its own web page with logo, news feed, etc. Each resume could link to the organizations and schools that it mentions and include their logos and information. Are document databases repeating history? While many to many relationships and joins are routinely used in relational databases, document databases and NoSQL reopened the debate on how best to represent such relationships in a database. The debate is much older than NoSQL. In fact, it goes back to the very earliest computerized database systems. The most popular database for business data processing in the 1970s was IBM's Information Management System. Originally developed for stock keeping in the Apollo space program and first commercially released in 1968, it is still in use and maintained today, running an OS 390 on IBM mainframes. The design of IMS used a fairly simple data model called the hierarchical model, which has some remarkable similarities with the JSON model used by document databases. It represented all data as a tree of records nested within records, much like the JSON structure of Figure 2.2. Like document databases, IMS worked well for one to many relationships, but it made many to many relationships difficult and it didn't support joins. Developers had to decide whether to duplicate, which is denormalize data, or to manually resolve references from one record to another. These problems of the 1960s and 1970s were very much like the problems that developers are running into with document databases today. Various solutions to solve the limitations of the hierarchical model. Various solutions are proposed to solve the limitations of the hierarchical model. The two most prominent were the relational model, which became SQL and took over the world, and the network model, which initially had a large following but eventually faded into obscurity. The great debate between these two camps lasted for much of the 1970s. Since the problem that the two models were solving is still so relevant today, it's worth briefly revisiting this debate in today's light. The network model. The network model was called the Conference on Data Systems Languages, CODASIL, and implemented by several different database vendors. It is also known as the CODASIL model. The CODASIL model was a generalization of the hierarchical model. In the tree structure of the hierarchical model, every record has exactly one parent. In the network model, a record could have multiple parents. For example, there could be one record for the greater Seattle region, and every user who lived in that region could be linked to it. This allowed one and many to many relationships to be modeled. The links between records in the network model were not foreign keys.